During this walkthrough, I'd like to show how Kapstan CD can serve as a better, more streamlined, and self-service experience for continuous delivery than Flux or even ArgoCD. To start, I wanted to anchor us on the developer workflow. It's pretty standard. Developer pushes code, GitHub Actions is used to build and push the container to your registry of choice. ArgoCD or some CD agent gets invoked to pull the latest version change, as well as any Kubernetes config changes, and the Helm gets upgraded onto the cluster deploying the application. Argo is great for two main reasons that you're probably aware of. The first is a GitOps functionality to track and manage Kubernetes configs, which is usually the reason that teams move away from GitHub Action scripts. And the second is an automatic syncing of Kubernetes configs to the cluster, which is useful, along with a UI interface for DevOps to view the deployed Helm and some basic logs. That being said, at Kapstan, we also saw a few issues with this approach. The first is a lack of developer self-service resulting in ticket ops. The second is limited rollback capabilities in the case of deployment failures. And the third is an unintuitive observability workflow. So jumping in, the issue of ticket ops and not self-service is very prevalent with Argo, because in Argo, GitOps is the only way that configurations are managed and deployed. Developers aren't familiar with GitOps, especially as configs get more complicated, such as managing multiple environments or properly encrypting and managing secrets. This typically results in application engineers firing off tickets to the DevOps team for one-off configuration changes, such as setting up new environment variables or secrets or changing autoscaling parameters. This back and forth of ticket passing interrupts developer workflow, and it isn't really continuous delivery at all. The second is application rollbacks. Let's say an incorrect config was pushed to the GitOps repo, causing the application deployment to fail. ArgoCD acts accordingly and rolls back the change. However, your GitOps repository still contains the updated incorrect configurations. This requires manual work to fix, typically on the DevOps team. And the third is the lack of observability. In Argo, DevOps teams have to check specific pods to view deployment logs. There's also no built-in performance metrics or resource usage or other useful trends. Obviously, you can't expect a full-blown observability solution, but something here would be nice for developers to use and triage application deployment failures. Kapstan solves these three challenges by building a unified workflow for Kubernetes configuration management. Simply, we give a GitOps experience for platform team who wants to maintain version control in YAML. We offer a self-serve UI for developers. This self-serve UI is programmatically controlled by DevOps, but this is an easy way to offer developers an easy-to-use UI. There's no more ticket passing back and forth for environment variables or secrets. And behind the scene, Kapstan CD merges the two together and upgrades the Helm onto the cluster. Now let's see how this works in a demo. Kapstan is built around the concept of environments, which is nothing more but a collection of infrastructure resources and applications. What you're looking at right now is a single interface that shows everything inside a single environment. Specifically, this is a sample dev environment that we call Pet Store Dev. For developers, Kapstan provides a fully customizable abstraction over Kubernetes. So what you see here is a list of infrastructure resources, such as a NATS queue or a SQL RDS database, or Kubernetes container services, such as product service, order service, DevOps bingo. These are all microservices that are deployed inside a VPC in an EKS dev cluster. And all of this resides in your own cloud account. So how does continuous delivery work in Kapstan? First, we would need a container service. We do have a few here, but let's just start with the creation of a new container service, because I'd like to show you how easy it is for a developer to create a new Kubernetes container service in Kapstan. It's as simple as clicking on the plus icon, clicking container service, entering a container service name, pointing to a container registry of your choice, selecting the image repository and the image tag, and clicking confirm. Upon clicking confirm, a Helm template that is preset by the PulsePoint DevOps team gets installed on the cluster. Kapstan also comes with pre-built, well-architected templates if the team would like to use it. For the purposes of this demo, I'm going to show you an existing container service that we call DevOps Bingo. Let's just take a look at what the values.yaml file looks like, both with and without Kapstan. So without Kapstan, this is what a values.yaml file may look like for DevOps Bingo. Take a look at all of these environment variables. Each one of these would have been a ticket that a developer perhaps has sent to the DevOps team. With Kapstan, you remove ticket ops. Using Kapstan, this is what your new values.yaml file can look like. Using just a few declarations in GitOps, the DevOps team can choose to expose certain Kubernetes configurations that will be read from the developer UI in Kapstan. The configs that will be read in from the developer UI need to be defined here in a kapstan.yaml file. In this case, the DevOps team has given developers permission to modify certain configurations such as hardware resources, auto-scaling, image version, and environment and secrets variables. So let's see what this looks like from a developer's point of view. In the Overview tab, as a developer, I have the ability to select the image version and deploy with one click. I can also take a look at some basic system metrics such as service utilizations, CPU, and memory used, all within the same pane of glass. In the Configure tab, I'm given a lot more options. Remember, the DevOps team, via the YAML file we just showed, has given a developer like myself the ability to modify certain parameters that will be read from within the UI. Let's just say I want to add a few environment variables. As a developer, it's as easy as this. And click Save. No need to raise a ticket with a few new environment variables that need to be sent over to the DevOps team. Let me add a secret now as well. Let's just say that I'm using SendBird, which is an in-platform chatbot, and I need to add a new sacred API key. How would I do that? I mark the lock, and the variable is immediately stored as a secret in your own cloud, in this case, the AWS Secrets Manager. I see here that the DevOps team has also given me the ability to modify scaling parameters within the limits set by YAML. So I can change to auto-scaling, and based off of these, I'm allowed to now change the number of pods, as well as the target CPU and memory utilization. I can even scale using Kata, based on triggers such as queue length. All of that comes built in with the Kapstan platform. Now let's just say I'm ready to deploy my changes after making a quick change to hardware to run on AMD. So how does this work? It's easy. From a developer's point of view, they have a one-click deploy solution. So while this is busy deploying, it might be worth explaining what's happening inside the Kapstan CD engine. As we've seen before, under the hood, Kapstan is dynamically creating the Helm chart by putting together two pieces: the YAML defined by the GitOps by the infra team, and the values provided by the developers in the UI. The Kapstan CD engine then upgrades the final Helm chart onto the Kubernetes cluster. So it looks like the application deployment is complete, and oh boy, it looks like there's been a deployment failure. So now what? With Kapstan Continuous Delivery, it's really simple. In a single click, a developer can access the application and deployment logs to troubleshoot the problem. Since Kapstan is helping to manage the Kubernetes cluster, we have access to live logs in real time with a single click. Developers would also have access to a basic level of application performance metrics. This comes built in with every single container service. But how are we going to solve this issue? Well, the first thing is, much like ArgoCD, Kapstan is automatically rolled back to the previously most healthy state. In another click here on Configure tab, the developer can easily roll back changes and view their configuration changes that caused the failure. If the developer just simply wanted to roll back, all they need to do is click on this rollback button right here. But for the purposes of this demonstration, as a developer, I can come to my hardware, make the change, and deploy. All of this without that GitOps missing feedback loop. As a final example, let me show you how a DevOps team would limit the configuration capabilities for a developer. In the DevOps Bingo container service, recall that the DevOps team has given developers permission to modify all these Kubernetes configurations. But let's just say that the team only wanted to give the developer access to modify the environment variables. Well, in order to do that, all the DevOps team needs to do via GitOps is specify in the Kapstan.yaml file the specific Kubernetes configurations that developers are allowed to touch. You can see here that developers now only have access to modify environments and secrets and image version. They no longer have access to modify scaling, hardware, networking, config volumes, and other configs that were previously available. And as soon as this is uploaded, the Kapstan configure UI now looks like this. Developers are allowed to modify environment variables and nothing more. So to conclude, why Kapstan CD? Well, it accomplishes all of what ArgoCD does, but with these 3 additional benefits. A GitOps plus developer self-service mechanism to manage configurations on microservices, deployment rollbacks managed by developers with no GitOps missing feedback loop, and built-in observability for your developers from day one.